Okay, good afternoon, everyone. Today we are joined by Grady Gobongo, a techpreneur and innovator focused on building solutions that improve productivity for students and young professionals. Today he's going to be taking us through an exciting demonstration of using Python to translate your insights into infographics. Take it away, Grady.
Good.
Hi, Grady. You have a bit of an echo at the back.
Yeah, just trying to think. I don't know if it's gone now.
It's gone. Yes, thank you.
I mean, all
We can hear
right. Perfect. Perfect. All right, great. Let's get into it. I apologize about that. All right, so today we will be working with Python still. If you saw our previous webinars, we worked with files, manipulating data, getting insights from our data, and today we are going to visualize that data. I will use the exact same data set, more of like a follow-up. So I'll share my screen. I will show you guys the data set, and we will get into actually visualizing that data. There we go. Great. My screen is live now. Here we have PyCharm. For those that forgot, this is the environment we use for writing our script or code. And this is the data. I believe I shared it in the drive. We have a drive and it's public to everyone. So it's in the drive when I did the previous webinar. And basically, this data set contains information about students and several factors that may influence their academic performance. And yeah, we went through it the last time. So we're going to use this data. We're going to use the columns that are here. And we're going to use quite a number of columns. We have hours studied, attendance, access to resources, sleep hours, motivation, and all that. I'll close this data set. So the first thing we want to do here is we want to import a library we call matplot library. So this is a library we use to visualize data. There's a link in the chat And that link has all the charts that this library offers. There's quite a number of charts that this library offers. So it supports many different types of charts, line charts, scatter plots, bar charts, horizontal bar charts, and all the charts you can think of. So we need to import the library first. Okay, so just give me a sec. Right. Right, so importing is quite simple. This is the library. Don't worry, I will not be writing code. Yeah, I just do the importing by myself. So this is the library here, matplotlib.pyplot. This is how you import it into your IDE. And you have to import the pandas library as well. For those that remember, pandas is what allows us to actually manipulate our data. All right, so the first thing we need to do is to load our data set. I have the scripts pre-written already, so I'll just copy and paste to make things quick. But I'll take you through them just so you actually understand. So the first thing you do is to actually load your data set. You have a variable. This is where your data set is gonna be kept in your code. And this is the actual file of my data. So it's this file over here, student performance vectors, this Excel sheet. So we write it exactly as it is. So what print does is basically prints. It displays, it renders what you want to do. So it shows you what you want to do. So what I want to print here is a preview. Here, what I want to print is the information of my data that's here. And what I want to print here is a description of my data. So the functions are quite simple because description, you just type as describe. Information is information. So, and to preview, it's head. But yeah, all these things can be done with simple Google search. So I'll quickly run the script. Yeah, there we go. It gives me just um, what I need to know about my data. It gives me the columns in my data sheet, in my Excel sheet. It gives me the actual data as well. And it even gives me the data types and whether columns are filled or empty. So with that there, what I want to do now is I want to start plotting. For example, the first thing I want to do maybe is I want to check, let me add a comment here. I want to check distribution of exam scores. So this is distribution of exam scores. Please don't mind the spelling. Distribution of exam scores. So I will take that script and put it there. So this is a plot. What I can also do here is I can just put another comment with a very simple prompt that will give you the exact same code. So you can use whatever Gen AI tools you are more comfortable with. Even Strawberry AI can give you this code. I actually tested it and it worked. So You can use a simple prompt, generate Python code using MATLAB to create histogram showing distribution of exam scores. And it's going to give you the exact same code that you see here. So the nice thing about this library, the structure is always the same. If you take a look at what is showing here, you have PLT. PLT is it's basically the default function. It's required to be there. So plt.figure. Plt.figure generates that whole figure for you. And then in brackets, you just put the figure size, how big you want your charts to be. So 8 to 5. 8 is how long it should be, basically the length, and then 5, the width. Plot.hist. So hist is histogram. Now with here, you can put different type of charts. If you want a line chart, it's just line. If you want a bar chart, it's plt.bar. So if you look at the documentation I sent in the chat, you can see all those type of charts and they have all the names there. So it's easy for you to just put in whatever type of chart you want. And everything that you see in bracket comes from the Excel sheet. It comes from your data. It comes from the columns in the data. So plot.title. This is a title you insert yourself. Distribution of exam score. X labels. You guys know how a chart looks like. You have X labels, you have Y labels. X labels, it comes from the chart as well. I mean, from the data as well. My X labels, I want them to be my exam scores as I'm checking the distribution of exam scores. And my Y labels, I want it to be the number of students. So basically, that's how you plot. So most of the charts will have, or rather, most of the plots or visualizations will have this structure. You need X labels, you need Y labels, you need a title, and you need the actual type of chart you want to use. And obviously the size of the chart. So if I run this, it gives me a chart. Python already has its own UI in which it gives you the chart. You don't need to worry about how the chart is gonna pop up. It does that for you. So here you have the exact same information I inserted when I was creating my chart, my exam scores, and this side, the number of students. And as you can see, this is based off the data. So if you want to compare, you can go open the spreadsheet, open the charts, and actually compare that the data is accurate. But trust me, it is. And here we can see that, you know, about most of the students, which is here, this is about 1.5 students, 1,500 students, get a score of about 70 here. And these ones at 80, it's less than 100. You can see below 60, it's less than 100 as well. So you plot, you read the chart. So I'll comment this out. I'll comment this out so we can do a different type of chart. Maybe we can do a scatter chart. So what we can do is we can look at the hours studied versus the exam score. So it's going to determine whether studying is generally leads to better academic performance. So that will be based on our data. And again, you will see that the code uses the same structure. Let me just put a comment here. This is going to be hours studied versus exam score. This exam score. So again, we see the exact same structure. You have the figure size. You put in the size you want over there. You have the type of chart you want to use, which is a scatter chart now. So I want to have a scatter plot. So I have plt.scatter. I have my title, I have my X labels, and I have my Y labels. In this case, my X labels, our studied, my Y labels is the exam score. So me running this gives me a scatter plot. You can see all the students there. Now, let us just read this data for a bit. We can see that students that are studying between 10 to 30 hours are the ones hitting between 90 and 100. And funny enough, the ones studying for more than 40 hours are about 70%. I mean, are hitting a score of about 70, which is quite odd because they should be the ones getting 100. But anyways, this again is from the data. And you can do as many charts as you want. Do you can do as many comparisons as you want. It works the same way. So another thing we have here is there's some options when you do a plot. Once this UI pops up, it gives you options to actually edit. So for example, you can make the chart small, you can move it however you want because you can actually download this chart and save them. So yeah, whatever you want to do with the chart, and you can actually download it, save it, and use it however you want. So I'll comment this out as well. I'll comment this. Okay. By the way, I comment out codes. When you comment it out, it means it won't run. So you can just comment it, plot out and then run the next one. Because if I leave it active, it's gonna open all these plots, all these charts. And right now I just wanna open one. So let us do maybe we can do a bar chart. Yeah, we can do a bar chart. Maybe the bar chart, let us check. Okay, let us do something different. Let us check missing values. Let us check missing values in our data set. So the structure remains the same. The structure remains the same as you can see. You insert all the values that you want to use. But what I'm going to do here, I'm going to do something different. I want it to also display the missing values on my console, just so we can compare. So I'm going to add that here. I'm just going to create a variable missing. It's now. So it's basically is now, as in there's nothing. Yeah, so it's there we go. Uh, print. Oh, so I will run this code here, and I just want to show you. Okay. Oh no, sorry about that. Let me just delete this. It's the wrong code. Yeah, there we go. Missing values in data set. Yeah, so this is a bar chart here, as we have specified there, as you can see. So what I did here is I added my own line to display the output in the console as well. So it checks the columns and it gives us how many missing values we have in that column. And if you take a look, we have most of the columns have one missing value, but the teacher quality, we have 79 missing values. And down here, parental education level, we have 91 missing values. And distance from home, we have about 68. So that should reflect on the chart as well, as you can see. So I'll just expand it. Okay, so trying to expand it with your cursor doesn't really work. That's why these tools are needed. You can just do this so that you can see all the values. So as you can see, the teacher quality, it's quite high. We only had 3 columns that had high missing values, and it reflects on the chart. So yeah, that's a way of checking if if these charts actually work with your data. But basically, that's that. It's actually quite easy to plot and create charts. It's actually the easiest thing to do rather than analyzing your data, trying to extract key insights, trying to do this left, right, center. This is the easiest thing because the structure always remains the same. You can literally copy the same code for each chart, and all you do is just change the columns you're trying to work with and the bar type. So if you open the document, or rather the link that's in the comments section, you will see all the types of charts, and it has the structure on how to write it. So it's the easiest thing to do. And yeah, basically that's that. If you want, you can test out the charts yourself. I'll be taking questions if there's any questions. And yeah, that's that. Very, very light stuff.
Thank you so much, Grady, for this demonstration. Please feel free to unmute yourself and go ahead, ask a question.
Sorry, let me just mute myself because I cannot really hear the questions.
All right. There is a question from the chat. Someone asks, are there costs attached to using the app and or charts? So I think, are there any costs attached to using
Let
Python?
me just look at the question and answer it.
Sure.
Hi, Grady. I can ask the question directly if I may. Am I audible? Are there any costs to using Python specifically this platform in managing your projects and using these charts?
Okay. Costs. No, there's no costs in using this. So MATLAB, it's a free library. It's part of Python. So once you have the IDE running, which is PyCharm, obviously if you're using the community version, it's free, but there are enterprise versions which you get to pay for, but the library is free and you can use it however you please, however you want. You can use it on a larger scale. You do not have to pay for it. There's no cost.
All right. And on the system, thank you, Grady. Via the link that you'd sent in the chat, I'm seeing there's 3 different download options. It says download Juniper notebook, download Python source, and download zipped. There's a specific chart that I'm actually looking at. Which one do I go by? Is it the Juniper rather?
Yes, it's Jupyter. That's the one you want to download.
All right. Thank you so much.
Thank you.
All righty. If there's nothing else from anyone else, have a lovely day and enjoy the rest of your week, everyone. Goodbye.